I'll do that right here with you. Y equals x is just a straight line going through the origin. Y equals x squared is going to be a parabola that goes through the origin. Y equals x cubed is going to look something like this. Square root of x is going to look something like that. 1 over x is going to be the upper right quadrant, quadrant 1, and then quadrant 3. 1 over x squared is going to look like this. 2 to the x power. Doesn't go down, it starts, and then it goes up like this. And this crosses through at 1, and the second, this will go at 1, 2. Y equals 10 to the x is closer to the axis, and it goes up really fast. So that's still at 1, but when we get to 1 here, it's going to be at like 10. This is a horrible scale. If I was a better teacher, I would scale that out better, but hopefully you get the idea. Maybe I should just move this up to like there and call that 10. All right, this is y equals the absolute value of x. Goes out in both directions like that, and it creates a v. And fill in our domain and range for each of these. For this one, we go from negative infinity to infinity. For both domain and range, because it goes up and down forever. On this one, the x values go all the way to the left, they go all the way to the right, so we're going to go from negative infinity to infinity. But my y values don't. My y values start at 0, and 0 is included, because there is the point 0, 0. So we use a bracket on the left-hand side. But since it goes up to infinity, we use a parenthesis on the right-hand side. X to the third goes to left and right forever and up and down forever. So we have negative infinity to infinity for each of these answers. Now, square root of x, it starts at 0 and goes to the right. So we'll have a bracket and then a parenthesis. And the range is the same thing. It starts at 0 and goes to infinity. This one is a little bit different. This goes from negative infinity to 0, not including 0, and then goes from 0 to infinity, not including 0. So this one's a little bit different. What we do for this one is we go from negative infinity to 0, and then we put a little u here, which means union, of 0 to infinity. So it's combining, that u combines both of these. So it's pretty much everything except for 0. The range would be the same thing. It goes from negative infinity to 0, doesn't include 0, then goes from 0 to infinity. Now, 1 over x squared has the same domain as 1 over x, everything except for 0. I'm trying to write faster than my computer will allow me. Now, for the range, though, I don't have anything on the bottom. I just go from 0 to infinity. So 0, not including 0, all the way up to infinity is going to be my range. Finally, the last set, these exponential functions are going to have the same domain and range because they look fairly similar. And it's going to be greater than 0, so not 0, and it's going to go towards infinity. So 0, infinity. The range, oh, I hope everybody saw that I did that wrong. What I did is I actually did the range goes from 0 to infinity. The domain goes from negative infinity to infinity for both of them. Absolute value of x, the domain is again from negative infinity to infinity, but it starts at 0 and goes up. So that includes 0 and then goes towards infinity. All right. Now we're going to look at some transformations. We're going to see what each of these transformations does. All right. If we have a function and we add a value to it, say the value is greater than 0. Say if I have f of x plus 3, that moves the function, it translates the function up c units. Now if it's less than 0, it's going to translate down c units. Now if it is 0, then it doesn't do anything because plus 0 doesn't do anything. Now if we put some number out in front of the function, say if that's 3 times f of x, that's going to vertically stretch a function by a factor of c. Now if it's between 0 and 1, that's going to vertically shrink by a factor of c. If there's a negative, so that's like saying if c goes below 0 in number 2, that's going to be a reflection over the x-axis. Now if we have x plus c in the parentheses, if c is greater than 0, that's going to translate the function to the left, c units. If it's less than 0, so if it's x minus 2, that's going to translate to the right, c units. Now if we have c inside the parentheses here and it's greater than 1, what that does is it's a horizontal shrink. By a factor of c. And if it's between 0 and 1, it's a horizontal stretch. Now if it's f of negative x, that's going to be a reflection over the y-axis. All right, so now we're going to do things to our parent functions. 2 plus square root of x. Now let's start with our square root of x. Hopefully everybody remembers that the square root of x looks like this. Now this 2, this is the same thing as saying square root of x plus 2. So if I just move this up 2, because this is going to be a translation up 2, in red I will make the actual function, which will look like this. So this looks like that. Maybe I should even erase this. Alright, now sketch this graph. The minus 5 is a shift down, and the 3 is going to be a vertical stretch. Now vertical stretches are hard for some people to understand, and we'll actually get a better understanding as the semester goes along. But let's start with going down 5. 1, 2, 3, 4, 5. So the vertex, instead of being at 0, 0, is down negative 5. Now we're going to stretch it vertically. So if I go 1 to the right, instead of going 1 up, I'm going to go 1, 2, 3 up because it's stretched vertically by a factor of 3. Now instead of going 1 more up, I go 3 up. 1, 2, 3. and that will be there. So my function will look something like this. A good teacher should put little arrows on the end saying it goes on forever. Now, this is similar, but now we're doing with the x squared function. If I go down 4, 1, 2, 3, 4. Now the x squared function behaves a little bit differently. If I move 1 to the right in an x squared function, I move up 1. But if I move 2 to the right, I'm going up 4. If I move 3 to the right, I'm going up 9 because I'm squaring it. Now if I double that, if I go 1 to the right, I'm going up 2. If I go 2 to the right, instead of going up 4, I'm going to go up 8. So 1, 2, 3, 4, 5, 6, 7, 8. 8. And so this is going to be a parabola that's just stretched out vertically. Now this one is tough for some people to see. Really, this is the parent function y equals 1 over x squared. And we're shifting it with this and this. The x minus 2 is going to move it to the right 2. The 4 is going to move it up 4. So now pretend that this is our new axis. Now we just draw the x squared function. The x squared function starts up here, goes like this, starts up here, goes like that, and we're done. All right. Now, we know if we have a parent function y equals 2 to the x, 2 to the negative x and negative 2 to the x are two different functions. 2 to the negative x is like the f of negative x, where it's a reflection over the y-axis. So this one is going to look like this, where negative 2 to the x is going to be a reflection over the x-axis. So instead of going up like this, we're going to go down like that. So this is that function, and this one is that one. All right, now you can do your homework. Good luck.